I'm Algebra Annie, and I'm here to help you be successful in your algebra class. If it doesn't challenge you, it doesn't change you. Fred DeVito. Our learning targets today are: I can identify solutions of inequalities in one variable. I can write and graph inequalities in one variable.
For today's lesson, we're going to be graphing and writing inequalities. There are 5 different inequalities that you need to be familiar with. The first one is the less than symbol. We would read this as A is less than B. The next is the greater than symbol. You would read this as A is greater than B. The next is the less than or equal to symbol. You would read this as A is less than or equal to B. The fourth one is the greater than or equal to symbol. You would read this as A is greater than or equal to B. The last is the not equal to symbol. You would read this as A is not equal to B. The solution to an inequality is any value of the variable that makes the inequality true. Our first problem wants us to describe the solution in words. And our first problem is 3 plus x. This side is supposed to be less than 9. What numbers do we know that are less than 9? So I know that 8 is less than 9. So this whole side over here could be 8. I know 7 is less than 9. So all of this over here could be 7. That's smaller than 9. Well, I know 8.5 is, this number is smaller than 9. I also know that 8.99999999999 is also smaller than 9. So I can get as close to 9 as possible, but just never touch 9. All of those would have been smaller than 9. Well, what does that mean about x? If this entire side was 8, 3 plus 5 would have given me the 8. So x could have been 5. Well, this whole side had to be 7. 3 plus 4 is 7, so x could have been 4. If it was 8.5, 3 plus 5.5 would have been the 8.5, so it could have been that. So 3 plus what gave me 8.9999999? Well, I know that would have been 5.999999999. Well, all of these answers are possible solutions for x. We got to figure out what could we say that would include all of these numbers. This is the largest I could get and still have it be smaller than 9. So if this is the larger that I can get, this is really close to 6. I can't be 6 because if I was 6, 3 plus 6 is 9. I cannot be 6. But I can be anything smaller than 6. So my answers for x are going to be all real numbers less than 6. Another problem is 2 times p is going to be greater than 8. I need to find out what numbers are actually greater than 8. Well, over here, I know 9 is greater than 8. I know that 10 is greater than 8. Well, I know 8.5 is actually bigger than 8. I also know that 8.111111111 is greater than 8. I also know that 8.000000001 is also bigger than 8. All of these numbers are larger than 8. Well, what values of p would make these be answers for us? So if I wanted 10, 2 times what gave me the 10? Well, if I was looking for 10, p would have had to have been 5. 2 times what gives me 9? Well, if I wanted 9, p would have had to have been 4.5. 2 times what would have given me the 8.5? Well, if I was doing 8.5, 2 times 4.25 would have given me the 8.5. These are getting ever so close down to 4. So if p was 4, I would have actually equaled 8. I can't equal 8. I'm going to be larger than 8, which means p cannot actually be 4. It needs to be bigger than 4. So what are my answers? So my answer is all real numbers greater than 4. If I was 4, 2 times 4 is 8. I don't want 8. I want bigger than 8, which means I need all the numbers that are bigger than 4, so I'm actually bigger than 8. Now we're going to learn how to graph the inequality. Now before we graph it, this is the problem. B is less than negative 1.5. So I need all numbers that are smaller than negative 1.5. I know that negative 5 is actually smaller than negative 1.5. I know negative 6 is smaller than negative 1.5. What is really close to negative 1.5? Negative 2 is smaller than negative 1.5 and is actually really, really close. So let's use these ideas to graph it. So I need to draw a number line. So here's my number line. Negative 1.5 is the number in question. So here's negative 1.5. On the number line, I need a few numbers to the right. So I know that negative 1 and then negative 0.5. A few numbers to the left. This would have been negative 2. This would have been negative 2.5. My number line is counting by halves. We're looking at the number negative 1.5. This number right here is negative 1.5. Can I actually be that number? Can negative 1.5 actually be smaller than negative 1.5? If that cannot be a natural answer, you leave it as an open circle. Now all of these numbers, negative 2 is right here. Negative 5 and negative 6, they would have been more over here. Notice I found a lot of answers over here. That meant negative 1.5 is not an answer, but everything else on the number line this direction is a possible answer that I could use. All of these numbers over here are smaller than negative 1.5. So this is how you would graph it. Our new problem is r is greater than or equal to 2. What numbers are greater than 2? Well, I know 3 is actually bigger than 2. I know 4 is actually bigger than 2. Is there something really close to 2 but is still bigger? I know 2.5 is really close but bigger than 2. I know 2.1 is really close but even bigger than 2. So that is the greater than part. This is actually r is greater than or equal to 2. What number is equal to 2? Well, 2 is equal to 2. So these are all the numbers that I need to make sure that are included when I graph my line. So we have to graph it. So here's my number line. The number in question is 2. If this were my number line, I need to count a few to the right and a few to the left. Positives get bigger as they move to the right. They get smaller as they move to the left. So here's my number line. The number we're looking at is 2. So here's 2. 3 was an answer. 3 is right here. 4 is an answer. It was over here. 2 is an answer. That is right there. Notice all my answers are over here. 2 itself was an answer, so it is actually a closed circle, saying 2 is an answer to our problem as well. And all of the numbers in this direction are also an answer. Anything on our number line, starting at 2 and into the right, is a solution to this problem. The next problem they want us to graph is 7 is less than x. I need 7 to be smaller than all my numbers. So 7 is smaller than 8. I know 7 is also smaller than 9. I know 7 is also smaller than 8.5. I know 7 is also smaller than 7.5. 7 is also smaller than 7.00001. I can get as close as I want to 7, but notice that 7 is smaller than all of these. So let's go ahead and graph it. So here's my number line. The number in question is 7. A few numbers to the right would have been 8 and 9. A few numbers to the left would have been 6 and 5. 7 is the number in question, so I'm looking at 7. Can I actually be 7? No, which meant this had to be an open circle. It's not an answer, so it has to be open. All of these numbers, 8 is right here, 9, 8.5 would have been right there, 7.5 would have been right here, 7.00001 would have been really close to 7, but not actually 7. So I'm noticing all my answers are over here. 7 is not an answer, so it's open, but all the numbers to the right are possible solutions. Now 7 is less than x has the letter, the variable, being on the right side. And for a lot of students, this is extremely confusing and difficult to do. This is the same exact problem we just solved, but I want to show it to you in a different way. If you don't like the way that it's read, you can seriously pick it up and flip-flop the entire problem. So if you don't like the x on the right, if you want it on the left, put it there. If you don't like the 7 on the left, you want it on the right, put it there. You flip-flopped their places, which means you need to completely flip-flop the sign. If the alligator was eating the x, the alligator needs to still eat the x, is one way that you can help remember it. Now this might be an easier way for you to read and try and solve the problem. So I need all numbers that are greater than 7. Well, I know 8 is bigger than 7. 7.5 is greater than 7. 7.000001 is also greater than 7. So here is our number line. The number in question is 7. 8 and 9 are the 2 to the right. 6 and 5 are the 2 to the left. 7 is the number in question. 8 was an answer. 7.5 was an answer. 7.00005 is an answer. 7 cannot be, so it has to remain open. But all the numbers to the right are a possible solution. Same exact problem we saw before, so we flip-flopped the problem. Same answer, just for some students this is easier to read. Before we move on to the harder problems, I want to make sure we review how to flip-flop the inequality in case it is written in a method you do not like to read and you want to flip-flop it so it's in a method that's easier for you to read. So 0 is supposed to be larger than w minus 2. If you do not like it, because the variable is on the right, you can actually change it. So 0 is now on the right. W is now on the left. If I flip-flopped the sides, I need to flip-flop the inequality. If the alligator was eating the 0, the alligator is still eating the 0. So if I were to flip-flop it, my new problem would be w minus 2 is less than 0. Same exact problem, you just chose to flip-flop it, so the variable was on the left. This is read as 15 is greater than x plus 9. I want to flip-flop it so that the variable is on the other side. This is read as x plus 9, so you need to write what it said, x plus 9, on the other side. This is read as 15, so the other side needs to be read as 15, x plus 9, x plus 9, 15, 15. The inequality, the alligator, was eating the 15. It needs to still eat the 15. You flip-flopped the inequality if you flip-flopped the sides. Still read, it's the same exact problem. It's just now it's easier for some students to read. Let's pretend that you do not like the way that this is written and that you wanted to flip-flop it. I'm going to show you how to do that. So if this is what is written on the left, 6 plus 3k minus 2, if you wanted to flip-flop it, it needs to read that way on the new side. So 6 plus 3k minus 3. It needs to read that same exact way on the other side. 2 times the parenthesis of k minus 3. This is exactly how it needs to be read. 2 times the parenthesis of k minus 3. It's exactly how it was read. It is still read that way. If you flip-flopped the sides, you need to flip-flop the inequality. If the inequality was eating the 2 parentheses, the inequality still needs to eat the 2 parentheses. Same exact problem, you just chose to flip-flop it so it was easier to work with. Now we're being asked to graph the inequality 2 squared minus 4 is greater than or equal to w. Well, I don't know what 2 squared minus 4 is. I do know that it's greater than w, but I don't know what this number actually is. So we're going to do order of operations on the left side and figure out what we're actually dealing with. 2 squared is 4. So this is actually 4 minus 4 is supposed to be greater than or equal to w. Well, what is 4 minus 4? It is 0. 0 is supposed to be greater than or equal to w. You could either graph it this way, or you could choose to flip-flop the entire inequality if it is easier for you to read. If this side said w, this side needs to say w. If this side said 0, this side has to say 0. The inequality was eating the 0. The inequality still needs to eat the 0. If you flip-flopped the sides, you need to flip-flop the inequality. Now we're going to go ahead and graph this. We need our number line. The number in question is 0. A few to the right, a few to the left. Number in question was 0. I need to know numbers that are smaller than 0. Well, negative 1 is smaller. I know that 2 is smaller. That dealt with the less than symbol. But I also need the equal to. What number is equal to 0? Well, 0 is equal to 0. So 0 and everything else below make this statement true. W is less than or equal to 0. Anything highlighted in green is less than or equal to 0. Now we're being asked to write the inequality shown by the graph. So this is the number line that they're asking us to write an inequality for. So we're looking at a bunch of numbers. And these numbers are being compared to this circled number 3.5. This is an open circle, and since it is open, that means 3.5 is not an answer, but everything else this direction is. One of those highlighted numbers happens to be a 4. Is 4 larger or smaller than 3.5? 4 is larger. So 4 was a possible answer. If he is bigger, this is the greater than symbol. 4 is greater than 3.5. It's not equal to because it's open. So our answer is all numbers that are greater than 3.5 is how that number line is read. This is our new number line. We're looking at all of these numbers. So we're looking at all of these numbers compared to the number -3. So compared to -3. This is a closed circle. And since it is closed, that means this is an answer as well, which means I need an equal sign in there. Now looking at all the numbers that were also highlighted, -4 was one of the highlighted numbers. -5 is also one of the highlighted numbers. Are these numbers bigger or smaller than? I know the further down this way I go, the smaller my numbers get, which meant this is smaller. So my symbol is x is less than or equal to -3. And this is my answer. Now we're going to do a word problem. It says the members of a lightweight crew team can weigh no more than 165 pounds each. Define a variable and write an inequality for the acceptable weights of the team members. Graph your solutions. So we are going to go ahead and we're going to let W represent the allowed weights. There, we defined our variable. W is our variable, and it's going to represent the allowed weights. The word problem said that the athletes, that they could weigh no more than 165 pounds. So this means that their weight is somehow being compared to 165 pounds. I need something that is no more than 165. So coming up with ideas, I need a number that is not more than 165. Well, I know 164 is not more. I know 163 is not more. So this over here is smaller than 165. So it is smaller. So now the question is, could I be equal to? If I was equal to 165 pounds, am I more than 165? No, I'm not. So you could also be exactly 165 pounds and you would still not be more than. So your answer is W is less than or equal to 165. And now we're supposed to graph this. So here is my number line. 165 is the number in question. I need a few to the right. I need a few to the left. 165 is the number in question. Can I be 165 pounds and still not be more than? That is true. So 165 is not more than. All the numbers are smaller. This way are all the smaller pounds. So I defined my variable. I wrote the shortened English statement, made it a inequality statement, and I graphed it. We're done.
What did we learn today? I can identify solutions of inequalities in one variable. I can write and graph inequalities in one variable. And I look forward to seeing you tomorrow in class.